The topic is to connect your Arduino board with the breakout board and power it up, and then write the program to control your servo
Oh,
motor.
the thing is, I left my kit in the bus,
Ah, that's very
so
interesting.
I'll get that in Monday.
Yeah, that's fine. That's all right. So,
So
what
I
I
just have to get
observed
the.
is the last video that we did. There is no audio on it.
I don't know.
If you
Wait,
watch the
I'll
last
check.
video, there's no audio on it. So I'm
Uh,
gonna do a repeat of
Wait,
whatever I did
I'll
last
check.
time,
I'll
last
check.
class.
I'll check if you have audio now.
Yeah, there's no audio on it, so I'm gonna do a repeat of the same thing again. All right. So let me just go ahead and share my screen. Connected the camera. Okay. All right.
Yeah, I can see it.
Good. So this is the breakout board. Yeah, how does it go? Yeah, this way. Now, what are the pin out or pin connections that has to be done on the breakout board? This is what I'll explain right now. Yeah. So if you observe carefully, this is the jack where we connect the 5 volts, and this is
Um,
the power block terminal where we connect the 5 volts. Now the
so
extreme,
it's like 5 FPS.
sorry,
It's not clear. It's 5 FPS. It's not even 30 FPS.
what is
It's
30
like you're
amperes?
lagging. Frames per second.
Okay. So
So it's like 5.
this pin here is ground. This pin here is ground, and this is positive. All right. Though if you reverse it, there is a diode that will take care of ensuring that it doesn't power on the board, so that your Arduino doesn't fail, because we've given a diode here so that in case you reverse it here. But in case you reverse it here, the light wouldn't glow, so you will know that you've not done it correctly. Now, whenever you're connecting 5 volts to this pin, or one of these pins here, this jumper here connection should be between 3 and 2. If
We
you
are done
look
with
at it
that.
carefully, so it should be between 3 and 2. There should be a jumper between 3 and 2. So let me go ahead and connect a jumper between 3 and 2.
What does that do? Like, what does it do?
when you give a jumper between 3 and 2, it ensures that it powers up the Arduino board as well.
Oh,
So if you whatever you give, if you give a jumper between 3 and 2, if you give 5 volts here, it will go to Arduino board's 5 volts as well.
and if we don't?
The Arduino board has 5 volts here. So this
Yeah.
5 volts gets powered on when you do this jumper between 3 and 2, that is 5 volts. Now, in case you give a higher voltage here, you don't give 5 volts, but you give a higher voltage because you want to use this board for a different function and not for servo motor. That time, if you give a higher voltage, say up to 9 volts, then what we do is we connect it between 2 and 1, which means this supply will go to V in. So that will get connected to V in on the Arduino board. That is voltage in, so that it will power on the Arduino board by sending the voltage to this voltage regulator, and then it will convert it to 5 volts and then power up the Arduino board. So either ways, ensuring that whenever you're giving 5 volts here, just ensure that this is connected to 5 volts. The jumper is connected between 3 and 2. Whenever you're giving higher, more than 5 volts here, you'll ensure that you're connecting it between 2 and 1. Okay. So right now we'll go and connect it between 3 and 2. So we are telling that we'll be connecting 5 volts here. Even if you do not give 5 volts here, the Arduino's 5 volts will be available in all of these pins, wherever there's 5 volt. So even if you're powering up your Arduino, the 5 volts will be available on this board. But whatever you give to Arduino here is a maximum of 1 amps of current, not more than that. So in case you're drawing more current from this board, it will not be able to power on your sensors or your servo motors. So that's the reason what we do is we give up to 2 amps of current to this board and then power on the Arduino through the 5 volts. So I hope that's clear. Second jumper that's required is for this pin here. So it should always be between 2 and 3. Why 2 and 3? When you look at 2 and 3, it actually says diode. So it's for safety, where you allow the current to flow through the diode and not bypass the diode. So in case you want to bypass a diode where you know that, okay, you've done it correctly here and the LED is glowing, which means you've connected the polarities correct. And then what you do is you can bypass the diode and ensuring that it's only 5 volts and not more than that. So right now we will be giving it through the diode. And since there are 2 diodes here, up to 2 amps of current will flow. Each diode is capable of handling 1 amp. So they're in parallel. So 2 amps of current can flow through these diodes. So once we are done with this, our board is set. We can plug it onto the Arduino board. So let's go ahead and plug it on the Arduino board. Just ensure that the pins are not bent. So the powering, the connection is done. Right? Okay. Now you'll see that this board has been connected to the Arduino board. So let me go ahead and connect the Arduino board to the computer. And then let me power on the Arduino board. You'll see that this light glows, as well as the light inside the Arduino board also is glowing. How do I show you that? Yeah, see, even Arduino board is powered on. All right. This is because I've connected to 5 volts here. And even if you do not do it, by default, the pins are connected to 5 volts. So this, if you do it to V in, so whatever is given to V in will be available on this board. And when you give it a 5 volts, whatever is connected to 5 volts is available on this board. Just ensure that this is always connected to 5 volts. The light is glowing. Now we are good to go. Now let's see what each of these pins do. The pins on the extreme boundaries are exactly the same pins that have been connected to the Arduino here. So they go.
I actually know.
Sorry.
I saw the pin layout. I saw the pin layouts. I know what each pins to do.
Yeah, and it's mentioned on the board as well. It says 0, 1, 2, 3, 4, 5, 6, 7, and then this is 8, 9, 10, 11, 12, 13, and ARF and SEL, SCA, and ground. On this side, you have analog inputs, A0 to A5, and then you have the power pins, 5 volts, ground 3.3 volts. That goes here. Right. Now let's look at this part of the board. This part of the board here is for prototyping. You can connect any component if you want, say a resistor, or some circuit, or some probably you would want to connect a motor driver IC. We have more than eight perforations so that you could directly solder IC here and use it for a different purpose. Now, if you want to make it a motor driver board, you can still use it as a motor driver board by connecting, soldering an L293 IC on this, or a couple of transistors for a different function altogether. So this is for prototyping or a break or a general purpose board where you could solder active or passive components and then use it with your Arduino board. Now this part is where we connect the servo and the sensors as well. Now the extreme left, when I keep it this way, okay. Okay, the extreme pin here, these pins are ground. Okay, now why is that ground? Because I am keeping it in resemblance to how my servo motors are connected. Servo motor breakout is for my servo motor pin, you'll see that the extreme end is ground.
I know that. Like all of us know that.
Sorry?
All of us know that the servo's pin is that. Like
Not all servos. I'll show you a servo which I have. Do you see here? It's not ground in the in the extreme. It's 5 volts in the extreme pin. This is what I have done for my servo. So not all servos are that way, so you'll have to be careful. So like we see one of the servos here, the extreme pin is ground, then comes your VCC, which is 5 volts, and then comes your signal. So this is what the order is. We do the same order as what is there in the board as well. So the extreme here is the ground, then comes 5 volts, and the next pin is where you connect the signal. These pins can either be connected to these pins should actually be connected to the servo motor. So we just plug in the servo motor this way.
but why so many pins?
So I plug in the servo motor this way. When I plug in this way, there's one pin which is next to it, next to the signal wire, which is empty. What I do with that pin is I connect this pin to any of these digital input or output which is available here. So I connect, say if I want to connect this to pin number 3, what I do is I plug a wire from here to pin number 3. So that I will be able to control this servo and connect it to pin number 3. And in the program, I have to mention that it is connected to pin number 3. All right. So this is what will happen. The same thing goes for all of the other pins. So these two extreme pins are all individually 1, 2, 3 in the row wise. They are short. So how do I show you this? These two are short. These two are short. These two are short. Short. Goes on. And then this entire series is ground short, and this entire series is 5 volts. All right. So let's go ahead and connect our servo motors to the board. What we do right now is we do not power on the board yet. So if you have to power on the board, you have this power supply. On one end, you connect it to 230 volts AC through your power socket. And then on the other end, you get ground and 5 volts, V minus and V plus. This will be connected to your servo board.
I think we are done with that.
So you connect it in such a way that the ground is on the extreme end, and
Yeah,
then your 5 volts. So once this is done, your board will get powered on. Let's just go ahead and power up. Now you can notice that I have not connected the USB to this board. The USB is not connected to this board. I'll go ahead and power it up. Oh, yeah, this is extreme, and there's one more. So this goes. Yeah, let me power on the board. So when I power on the board, we'll see that the servo motor is active. I mean, the servo board is powered on, and then my servo motors are already in its direct. I mean, what do you call it as? The servo motor is also powered on. Now, what I've done here is I've connected the servo motors to these extreme pins here. I'll go ahead and do the connection again. Just remove it for now. So this is the board, and this is my robotic arm. Let me just power this up. I have the claw motor, which I'm actually connecting it to the extreme end on top. Okay. And then my right motor, I'm connecting it to the next pin. The left motor, I'm connecting it to the pins next to it. And the base motor, I'm connecting it here. Now in my program, I have connected the base motor to pin number 3. So I'll go ahead and use jumpers to make the connection. So pin number 3 is here. This is pin number 3. So I'll connect pin number 3 to the base motor. One connection is done. I'll connect pin number 5. Now the reason I'm connecting pin number 3, 5 is because they are PWM pins. I connected to the next one. I connect 6 to the next one. The 6 is actually connected to the right motor. And then I have the claw, which I'm connecting it to pin number 9. So I'm using pin number 3, 5, 6, and 9, and connecting them to the 4 servo motors. So this is a connection. My frame doesn't allow me to show you the entire robotic arm, so I'll show you one by one. In most cases, I will just get the robotic arm in this way. Okay.
nice, Papa.
Thank you. So this is a robotic arm. Right. How do I show it? Okay, cool. This way. Let me just focus on this. Yeah. So the robotic arm is here. I've made the connections. The power supply is here, and then if I go on and turn on the power supply, it'll power on the entire board. Now, before that, I'll have to go ahead and program the. I'll have to go ahead and program the robotic arm or the Arduino so that it could control the robotic arm. So let me go ahead and do that. Previously, we have actually seen a program where we are supposed to actually know the, program the boundary coordinates for the claw, which means what angle will the claw open and what angle will the claw close. So this is something that it is unique for each of your robotic arm. It's not universal because there will be a little difference in each servo, or the way you've connected, the way you've positioned your servo. So there will be difference. You'll have to figure out what is the extreme.
My one's in the bus.
Sorry.
Mine's in the bus.
Yeah.
I can't do anything.
Yeah, so you'll have to do it for each of the servo motors. So we'll go ahead and do for each of the servo motors. I'll just do it for one of the servo motors here. So let's see. Okay. All right, I'll quickly go ahead and open the Arduino program.
I thought you had a MacBook.
No.
Then?
No.
It wasn't yours?
There seems to be some program already on my robot. Okay, it's fine. I'll change the program. Can you see the Arduino program?
No.
No?
We can see, we can.
Okay. So I'll go ahead and open one of the programs that okay. Good thing that you can actually do is go to examples, Servo,
Example?
sweep. Just open this program in case you feel that you have to recalibrate your servo motors.
I'm done with that.
So I am just connecting. I know that I've connected pin number 9 to my clock, and I will just start from 0 and go up to about 90 degrees to just check. It's not advisable to start from 0. Okay, 45 to 90 degree, and say this is 90 to 45, and I'll go ahead and upload the code. COM16. So we'll see that the claw just opens and closes. So I know this is not complete. So let me go ahead and change this code to 0 to 90 and upload the code again. So 0 is the extreme. I think that's the maximum that I can take it out. But 90 is where it comes in. This is 90 and this is 0. So it is definitely more than 90 that I have to give. So let me go ahead and change it. So I'll make it at about 130. Now I'm typing 130 because I know for a reason that this particular servo is at 130 degrees. That's when it closes. I've done this previously. Yeah. So this is 130 degrees, the servo closes. So I'll have to keep this in mind. I should know that 130 degrees is where the clock closes and 0 degrees is where the clock fully opens. So I have to play anywhere between these two. Okay. All right. So we know it's connected to pin number 9. Now pin number 6. What is connected to pin number 6 is my other motors, and I can go ahead and do the same thing for the other motors. Finally, I'll just open the code that I had written for this particular program. Open recent MeArm program. Yeah, this is the program that we had written for MeArm. So here you'll see, I say clock open is 30 and clock close is 130. Okay. What have I done here? I've done 0. Okay, no issues. Clock see MeArm program. Yeah. And then right motor forward is 180 degrees. Right motor backward is 60 degrees. Those are the extreme ends. Left motor up is 90, left motor down is 0, base motor anti-clockwise is 0, base motor clockwise is 180 degree. Right, this is what it is. So let me just go ahead. Base motor I know is connected to pin number 3, and I'll make this from 0 to 180. 180 to 0, and let me just upload the code. We'll see the base motor just goes from left to right. All right, this is how I calibrate each of these motors using the sweep example program.
But we are done with that.
Yeah, you're done with that. So now you know the code. So what we do now is let's go ahead and
Copy paste.
make some changes to the code that we've written. I'm using the sweep program itself as a standard code, and I'm using this particular program to control the robotic arm.
Can
I'll
you?
just go ahead and explain what I've done here.
Yeah.
This is my comment line where I know the reference angle. Include servo.h. This is to ensure that the servo object is included. I mean, that's the header file. The library required to control your servo. Then servo class servo. I'm defining one servo object called class servo. And then another object called right servo, another object left servo, another object base servo. So I'm defining 4 servo objects. Integer position equal to 0, integer clock position is 30. Basically, I'm telling this will be the initial position.
Oh.
I don't have to give this, I can make the 0 itself. Okay. So right position, left position, base position. In case I'm individually controlling each of these motors, I can use it. Now in void setup, I'll have to declare which pin it is attached to. So clock servo is attached, right servo to 6, left servo to 5, and base servo to 3. Loop, this is the same code that is there in sweep. If you look at sweep program, I've used for position equal to 0, position is less than 180, increment position by 1 degree. And then my servo dot right. So here instead of my servo, I have clock servo or right servo, left servo, or the base servo. Right position, and then give a delay so that it takes the movement happens. Now here what I've done in this program, I've said clock servo right position plus 30. Okay. Now why is it that I've done it is because in my case here I said the initial position of the clock should be 30 degrees. Clock open is 30 and clock close is 130. So what I've done is I say, let's just go ahead and look at this. The lowest difference between any two motor is actually here, 90 to 0. All right, that's the left motor. Rest everything is greater than 90 degrees. Okay, so if I actually want to use a single for loop for controlling all the motors together, I have to ensure that the difference should maximum be 90 degree, because if I do anything more or less than this left, the more than this, the left motor will get jammed. The left servo motor will get jammed. So what I've done here is, I say whatever the position value is, add 30 to it. Okay, so if position value is 0 in the beginning, add 30 to it, so it will be add 30 to it, so it will be 30. It starts on 30. So the
Yeah.
ending value here is 90. So the position will go up to 120.
For the second one, was minus equals to 1.
Sorry?
For the second one, like after, yeah, the second one was minus equals to 1.
Yeah,
That's for going back to the
position
original.
minus equal to 1 is actually position equal to position minus 1.
Yeah, so because it's going back.
This can actually be written as position equal to position minus 1. So instead of that, you could also write it this way.
Okay.
So it will decrement from 90, no? It will go. So what happens here? Position minus 1, but what is the value of position? This. It varies between 0, 90 to 0. But even now, even then, when it is 0, it will still be 30 degrees. Okay. For the right servo, I'm telling position plus 60, which means the starting angle is 60.
60.
Yeah, 60. That's what it is here. And then the ending will be 90 plus 60 is 90
180.
plus 60 is 150. So it will
Yeah.
go between 60 to 150. The left motor will remain same because I've told left servo right will be the same value as position, and then the base servo will be written the same value. So it will rotate from right to left, 0 to 90 degrees. Now I'm doing the same thing in a reverse order here. So this is in one order and this is in the reverse order. So this will be from 0 to 90 and this will be from 90 to 0. So for claw servo it will be 30 to 120. For right servo it will be 60 to 150. For left servo it will be 0 to 90. Base servo 0 to 90. In this case here it will be claw will be 120 to 30. Right servo will be 150 to 60, and this will be 90 to 0, and this will be 90 to 0. So that's what it is. Let's go ahead and upload this code and see what happens to the robotic arm. Now it's a very interesting phenomenon that's happening. Let me just show you what's happening. Now this is happening because there's no
Nothing's
enough current
happening.
to control the motor. Okay, there's no enough current that's been supplied to the motor. So what I do right now is go ahead and power on my Arduino, the power on the servo motor board. I'm just going to remove this cable for now, and I'll be powering up the board so you can see where here. So this is a program. You can see the claw motor going. Now it's working now. Now it's working because I've connected this to a 2 amps power supply.
Can we use a joystick?
You can use a joystick, of course.
Okay. How?
I'll just show you another program that we've written.
Okay.
Let me go ahead and open another program. So this file, open recent. I have robot demo, serial read. Yeah,
Cessna. Look,
yeah.
Cessna.
So yeah, it's somewhere here. So on Google Drive. Ganesh. So yeah, servo with keyboard.
Oh, nice.
3, 5, 6, and 9. Yes. There's some challenge with this because of the initial position. The initial position had to be declared. We have not declared the initial position in this.
Can't I just copy paste?
Yeah, you could.
Yeah.
I'm not giving this code. You'll have to write this code on your own.
Why? Oh, wait.
Okay, let me just upload the code. I will turn off the power supply for now. Upload the code.
Okay. But still, I can't do anything because my kit isn't there with me.
The interesting part is for this to happen, we'll have to ensure that the Arduino board is connected to the computer and the 5-volt supply has to be given. So this is something that
So both the USB and the power supply.
both the USB and the 5 volts will be powered on. I mean the 5 volts will be coming from the USB as well as this board. Okay, there seems to be some problem. The uploading is not happening. Okay, problem uploading to the board because my Arduino board, the servo motors are consuming a lot more current than expected. So I'll have to just remove the servo connections for now. And then I'll upload the code. Let's say the board not found. Yeah, done. Oh, what did I do? No. Okay, fine. Yeah, I've uploaded the code now. So let me go ahead and connect the servo motors. The reason I had removed the servo motors is because it was resetting the board, and that's why I could not upload the code.
But why?
So now I'll go ahead and open the serial monitor. So I know for a fact when I type A, okay, cool. So serial monitor is not a good way to go. So I'll quickly go ahead and open PuTTY.
What's that?
That's another telnet function, but here you don't have to type enter every time you press a key. It'll automatically keep sending it. So let me just show this. Yeah, so I'm typing. Oh, fatal error writing to serial device. Okay, let me just power on the board. Okay, there's some problem. I'll open PuTTY again. Say serial from 16. Open A. Okay, let me just do it in this to the side. Okay, cool. So I'll say A. So I'm typing something in PuTTY here. You'll not be able to see it because PuTTY is such a feature. I mean, such a program where when you type it, if the command goes to the Arduino, it will not come on the screen. So A is actually controlling. A is actually controlling the robotic arm to go left and right. So B goes to right and then A goes to left. Interesting. Let me just minimize this a little. So, yeah, cool. I don't have to struggle. B, good. And then I think C.
C.
Yeah, C. D makes it go forward. C makes it go up. Okay, and then I think E, yeah, E makes it go forward,
Like,
and F makes it go reverse.
can't we like,
Okay, I'll show you this way.
uh,
E and F, F. Okay, and then I think G closes the claw. H opens up the claw. I mean, you can definitely change it to any other key. Right now, you can see that you want me to go pick up something. Let me go ahead and pick up something. Is it possible to pick up something?
what's a something?
Uh, Something on the board here.
Which is
Yeah, marker.
Okay,
what's
very
that?
difficult.
A pen
That's
cap?
a pen cap.
Okay.
Okay, I'll try doing this. Oh. Um, okay.
I think you can.
Oh, it knocked it down.
Good job.
Okay, good. It's come somewhere close. Ah, interesting. Okay, and then let me lift it up. G, E, F, G, E, F, D, and C. Yeah, okay. Not a nice way to command the robot. And I'm done lifting the thing. Just bring it up here. Yeah, so it's just lifted the pen cap.
My
Good job.
mom was asking if like this could do the cleaning of the house.
Oh, this is not as that strong enough to
I
do
know, I
cleaning.
know. My mom was asking that.
Oh, no, it doesn't. So I'm gonna drop this for now. What happened? Oh yeah, I have to click on this.
See,
Yeah,
it's
but then
C.
CD is not working.
Ah, no. Um,
8.
good job.
Okay. Here, what I've done is my USB is also connected. The 5 volts is also powered on. I don't seem to. Okay, let me just drop this for now. The C and D is not happening. Oh, it's happening. Maybe, see here the challenge is, it is not telling me what angle it is at. I think that's something that I have to write it in the serial port. So it actually helps me knowing that, okay, it is actually reached its extreme position. And G and H, right? Yeah. Cool. It dropped it. Good. So this is the robotic arm that we have right now. So I'll be wrapping up the session with this. I think we're good. We're good on time. If you want the code, you'll have to show me that you've calibrated your robotic arm and written the first program, and
Okay,
then I
so
will help
see,
you
so see this, see this.
get the keyboard control code.
So see this. See my screen. See, look.
1 second, 1 second. I will just share. Yeah, you can. 1 second.
Wait.
I'll just close this COM port. I'll close this. So you can download this thing. It's called Putty, Putty. downloaded from the internet. It's available, open source, free.
I'm done with the servos. Like only the code is left. It's this. Yeah. Look,
Yeah.
I'm done. I'm done with this.
1 second, 1 second. Let me share your screen. Oh yeah. Sorry, what am I doing? Okay, so your screen sharing is
Uh,
present to everyone. Yeah, I'll stop
but
mine sharing. You wanna share yours?
I am.
Okay, I'll
Look,
just yeah, I can we can see yours.
so I'm done with the. I have calibrated this, so I'm done with that. Now only the controlling part, only the code is left, the actual code.
But then this will only make it to go a particular position.
Then is there any other option?
This will this will go to a particular position. You can use that the while loop. Sorry, not the while loop, the for loop, where you increment and decrement this value. Go you use the same code from the sweep example and then modify it. Examples.
Uh, okay.
Is your numlock on? Numerical.
I have numlock on.
And you've also yeah, that's the reason why no your special characters are turned on. Okay, just go to file examples, servo, sweep.
Mm, I'll close this. No.
Uh,
Yeah. So yeah, that
yeah, so
next.
that's the code. So what you could do is declare all your objects in the beginning, servo, right servo, servo, left servo, and all of that. And then within the for loop, whenever you write my servo right position, you also write it for the clock, write it for the uh, base, and write for the left and right motors.
Okay.
That's it. That's what you'll have to do. So once it's done, let me know that it's done and possible share a video. And once that is done, I will help you write the code for controlling it with the keyboard.
Okay. Can you say again what shall I do?
Do what?
Like what should I do with this?
Yeah.
Yeah.
So
Like what code should I do? Make.
yeah, the code that I had written where it was just going in one random repeated motion where it used to go in circle, the claw used to go close, open, close, and open. I'll share the code right now. Let me share my code. Um, so this is the MeArm program. From the sweep, I've done this from the sweep itself. Same thing. Wherever there was servo, my servo object, I've written claw servo, right servo, left and base servo. I've set the integer positions to be 0. This is not necessary. Except this is necessary. Then in void setup, I've declared which pin each of the servo motors attached to. And in for loop, wherever there was my servo dot right position, I have written claw servo right position, right servo right position, left servo, base servo, and given a delay. I've just added these 4 things in uh, in place of servo my servo. I mean, so my servo dot right. This is the same thing that I've done from say examples. Go to servo and then sweep. So what I've done is here, wherever there was my servo, I've also said servo, right servo, and then servo, left servo, servo, base servo, servo,
Why five servos? I mean,
claw servo. It's not necessary, but then yeah. So here I will say my servo is attached to 3. No, in my case, my servo is attached to 3. In this case, we'll just put it 11 because I'm not connecting anything there. And I will say left servo dot attach. Then I say pin number 6. Then right servo dot attach pin number 5. It might be reverse base servo dot attach 5. Sorry, base servo
five.
is 3.
Yeah,
Right servo is 6. Left servo is 5.
9.
And then claw servo.
Wait, how are the five servos?
Sorry,
How are the five servos? Like this my servo dot attach 11 and then servo my servo. Why are there five of them?
I'm not connecting the fifth servo. This is not necessary. I can delete it.
So why
I
don't
can
you?
even delete it here. I'm just retaining what was there in the C program.
You're gonna confuse us like that.
Okay. So this is connected to pin number 9. And then close it. So we're done with this. In void loop, instead of having my servo, you say claw servo. And do the same thing again and again and again and again for all the servos.
Yeah, just copy paste.
So instead of claw, then make right, then make left, then make base. But then the challenge is you cannot have, see here it is 0 to 180 degree. You cannot have the claw move from 0 to 180 degree because the claw is only from 0 to 130. Alright, so you limit this to 90 because your left servo can go only between 0 to 90. So this can be plus 30. Base servo can go from 0 to 180, so it doesn't matter. So you can still retain it with position, POS itself, or you can make it plus 50 or 100 or whatever. And then your left servo is 0 to 90. Well, right servo is somewhere between, what is it for right servo? Forgot. Right servo is 60 to 180. So what I'll do is I will say 60 to 180 is position plus 60. So it will go between 60 to when it's 90, it goes 60 plus 90 is 150. So it will go between 60 to 150, the right servo. And then I have the delay and I do the same thing again here. I copy the same thing. Control C and then.
Not M, it's V.
So yeah, that's it. So this is a code that you will have to write for your robotic arm. You can go ahead and upload this and you will see the robotic arm dancing.
Okay.
All right. Okay, so I'll just close this for now. This is the program. Close it. I'll stop screen sharing. Okay,
Fine.
let me just show you the robot and then. Okay. All right. So let me go ahead and stop the screen sharing. Thank you for being part of the session. We just exceeded this by about
8
10
minutes.
minutes.
8 minutes.
Yeah, okay. Thank you. Good night.
Good night.